Hello everyone, welcome to my YouTube channel. Today we are going to discuss soil mechanics second chapter, that is basic definition and simple test. This is the first part of it. So what is three-phase system? That we will discuss first. Actually the soil, it is a mixture of solid particles, air particle and water particles like this. See like this, in this picture, see this one. Here there is solid particle, water particle and air particle. So the soil is actually a mixture of these three particles. But what happens, this is very complex in nature. We have to make it simple. So simplifying that, we will get a three-phase system. We put it in three layers, that is solid, water and air. So air, it is massless. Our mass can be neglected. So we always put mass or weight of air as zero, but air will occupy a volume. So we will have, for dry soil, we will have water absent. So this will become a two-phase system. See, the volume of water and the weight of water, that both will be absent in dry soil. So V represent the total volume. Here this V represent the total volume and M represent the total mass. So we always represent mass or weight on the right side and volume on the left side. That is our convention. So in the bottom we will represent the solid particle. Then above that, since water is not there, so we neglect it, then the air comes. So volume of air is represented as VA here and mass of air, that is zero. So that is dry soil two-phase system. Then we will discuss saturated soil two-phase system. So what will happen? Saturated means it's full of water. The total voids, V volume of voids, VV, this represent voids. Okay, so here the total voids is filled with water. There is no air. So what will happen? That will be like this. Volume of air won't be there, only water. Weight of water will be there and the volume of water will be there. That is the two-phase system. So now we will have three-phase system in which three layers exist, and two-phase system for dry soil and saturated soil, in which for dry soil water is absent and for saturated soil air is absent. So that is regarding three-phase and two-phase system. Now we will discuss some definitions. So volumetric relationships we will discuss. This is very important part. Five volumetric relationship exist. See, this is our three-phase diagram. This is our three-phase diagram. Here, volume of solid is represented as Vs, that is on the left side, volumes are represented, mass or weight are represented on the right side. So V and M represent the total volume and total mass, and Vs represent the volume of solid, Ms represent the mass of solid, Vw represent the volume of water, Mw represent the weight or mass of water, Va represent the volume of air, Ma, which is neglected because mass of air is neglected. So that is equal to 0. And Vv is the total volume of voids, that is Va plus Vw. Volume of air plus, sorry, volume of water. So that is the total volume of voids that is represented here. So that is given. Now we will discuss certain terms. First one is void ratio. This is a very important part. So void ratio is actually equal to, that we represent it as E. E is equal to volume of voids by volume of solids. See the volume of voids here. This volume of voids divided by volume of solid. So this part divided by this part gives void ratio. So here actually volume of voids, it cannot be zero anyways, because air or water, something may exist. Like sometimes if it's a dry state, then air might exist, and then when it is a saturated state, water will exist. So that is only two-phase system exists. One-phase system doesn't exist. So it cannot be equal to zero. Okay, volume of voids will never be equal to zero. So other than that, in the soil, water may be more than the solids present, or air may be more than the solids present. That is, volume of voids, this term can be greater than volume of solids. So that can be, each term can be greater than 1 also. So E can take any value greater than 0. Okay, so here it's given any value greater than 0. That can be taken by E. Also, for fine-grained soil, it will have so much of particles closely packed. But coarse-grained, it will be like this. Coarse-grained is like gravel, sand, and all, and fine-grained is silt, clay, and all. For silt, clay, and all, there is like so much of particles closely packed. So there is so much of voids in between. But in case of coarse grained, it is like this. So only this much of voids is present. There are particles are bigger and therefore the void ratio will become smaller. So always void ratio of fine grained is greater than void ratio of coarse grained particles. That is given here. Then for cubical array, this is a cubical array in which the soil will be in the loosest state and E maximum, that is void ratio maximum, will be 0.91. This is a diagonal array. In diagonal array, the soil will be in the denser state and E maximum or void ratio maximum will be 0.35. I hope this much is clear. This is regarding void ratio. Then the next one is porosity. Porosity, the same figure I am taking here. Here, porosity is equal to volume of voids by total volume. So, volume of voids is this part divided by total volume. Total volume is this much. So, volume of voids by total volume. So, this is a percentage, right? It is also called percentage voids. That is the percentage of voids present in total volume. So, this is expressed in percentage. So it can be like volume of voids always exists, na? So it is always greater than 0. Also, it is volume of voids cannot be greater than total volume, right? It can be only less than total volume. So therefore, we will have porosity of range 0 less than n less than 100 percentage. This is always except E, that is void ratio. Other things we are representing it in percentage, but in equations you put it in digital form like zero point 0.5, zero point 0.6, etc. or 1 up to 1 like that. So here it is always less than 1. So 0 less than n less than 1 if you're putting it in digit format. So like that. So this is also called percentage voids. Actually, for engineering purpose, we use always E instead of N, or E is more important than N. That is, void ratio is more important than porosity because here we have E equation as volume of voids by volume of solids, and N equation or porosity equation of volume of voids by total volume. Here, if soil volume of soil mass changes, then what will happen? Actually, here V as volume of solid, that is this part, this first initial part. This part is constant. When the volume of soil mass changes, actually volume of voids is changing, right? Volume of soil mass is changing, then volume of voids is changing. So in this term, in this void ratio term, volume of soil will remain same, but volume of voids change. So only no numerator is changing here. Whereas in porosity, it is volume of voids by total volume. So the total volume term also changed because volume of voids is included in this total volume. Total volume is equal to volume of voids plus volume of solid. So because of this volume of voids, the total volume also change. So the effect of change in volume of soil mass occur in both the numerator and denominator. Therefore, that is very complicated and thus it is very inconvenient to use. So we use always E instead of N in engineering purposes. Now we will get the relation between porosity and void ratio. So 1 by n, that is equal to we reverse it. So n is equal to volume of voids by total volume. Now, so we reverse it. 1 by n is equal to v by vv. So v means total volume is equal to volume of solids plus volume of voids by volume of voids. Then if you split it, we will get volume of solid by volume of voids plus volume of voids by volume of voids, which is equal to 1. So then we are taking this volume of solid downward. So it become 1 by volume of voids by volume of solid plus 1. Then this, what is this? This is void ratio. So that is 1 by E plus 1. So this we put it as 1. So from this relation, you can arrive at two relation in which we are giving expression for n and other expression in which we are giving value for e in terms of n. So from here we will have 1 by n is equal to 1 plus e by e from this. So that is equal to n is equal to e by 1 plus e. Also from this you can put 1 by e is equal to, from this one we can put 1 by e is equal to 1 by n minus 1. So from this we will get e is equal to n by 1 minus n. So these equations are really important. There are many questions, problems you get to solve from by using these equations. Okay. Then the next one. Then the next term is degree of saturation. We represent it by SR. That is equal to volume of water by volume of voids. So actually here, how much it is saturated. In the volume of voids, how much saturation is there or how much water is present. That is what it means by degree of saturation. That is volume of water by volume of voids. So actually the total can be filled. The total volume of voids can be filled with water, or it can be like dry state. If it is in the dry state, then the volume of water doesn't exist. Only volume of air is there in total volume of voids. So it can, SR can take the value from 0 to 100. If it is in dry state, then it will be 0. If it is in saturated, fully saturated state, then it will be 100 percentage. That is regarding degree of saturation SR. Then the next term is air content. Air content is represented as AC. That is like the other part of degree of saturation. If in the total volume of voids only water, if you're considering the water present, then that is SR. And if you're considering the air present, then that is air content. So in the total volume of voids, if air, that term is taken, then it is air content. AC is equal to VA plus VV. Similarly to the SR, it can take the value from 0 to 100 percentage. Because see, volume of air when it is full, that is if it is in the what state, dry state, then it will take the value of 100 percentage. That is when VA is equal to VV, that is in the dry state, then it will be 100 percentage. And if it is fully saturated, then it will be 0. That is the reverse of this. Here if it is for fully saturated, then it is 100 percentage. Here it is 0. Similarly, if it is in the dry state, here it is 100 percentage, but here it is 0. So we will have AC plus SR is equal to 1, right? Because AC is VA plus VV and SR is VW by VV. So it together becomes VA plus VW, sorry, VW by VV, which is equal to 1. So this relation also indirectly we get. Okay, then the next one, last volumetric relation is percentage air voids. We represent it as Na. Remember this term Na. From this you will get the relationship. Na is equal to Na. See, Na is equal to Na suffix C. So, sorry, here I have written it as capital. It is small letter. Okay, AC. Okay. So here Na we can represent it as NaC. So N here is porosity, AC is air content, which we have studied here. So from that we will get a relation N is equal to volume of voids by total volume into AC. AC is volume of air by volume of voids. So cutting this two, we get volume of air by capital volume is equal to Na, or percentage air voids is the ratio of volume of air by total volume. Then for dry soil, what will happen? The total volume of air is equal to total volume of voids. Then that term becomes what? Volume of voids by total volume. What is that? That is porosity. So Na becomes N when volume of air is equal to volume of voids. Then for saturated soil, we have volume of air is equal to zero because the total volume of voids is taken by water. So then in that case, Na becomes zero because Na is equal to Va by V. So Na can take the value from 0 to N. N is the porosity. So this is regarding the volumetric relationships. I hope you have understood this video. We will discuss about coming the remaining portions in the next video. If you like this video, do subscribe, share with your friends, and in the description box you will get questions regarding today's topic. Thank you so much for watching my video.